Okay, so this is a quick review of scientific notation. I want to remind you the definition is when a number is written as a product of a factor and an integer power of 10. The factor, the front part, must be greater than or equal to 1, but less than 10. So it's got to be between 1 and 10. So I'm going to show you what that looks like. So here's some examples of scientific notation. Notice the factor, the front part, all these numbers here are between 1 and 0. Even though it has a negative, it's okay, between negative 1 and 10, I'm sorry. So between 1 and 10. So 3.2, yes, between 1 and 10. 7.8, between 1 and 10. 5.1, 1 and 10. Notice all of them have one digit and then the decimal. Okay, so those are the factors. The factors themselves have to be between 1 and 10. Now the powers of 10, they could be big. This is going to be a big number, a small number, a big number, a really big number, and a small number. So those powers are going to be fine if they're negative or positive. It's here that you're looking for to see if there's scientific notation. If I show you some non-examples, these are not examples. Take a look. 45.1 is not between 1 and 10. 0.78 is not between 1 and 10. 101.3, 72.110, and 10.1. None of those are between 1 and 10. So this is not considered scientific notation. Okay, so those are examples and non-examples. Now I'd like you to go over and see how I actually change something from scientific to standard form. So here it is, 3.2 times 10 to the 4th. I can think of this 10 to the 4th as 10 times 10 times 10 times 10, which is 10,000. And if you were to take a calculator, you could multiply these out and figure out that answer. However, there is a faster way to get this. What you could do is you can start with 3.2. And with 3.2, the decimal starts here. You're going to move it over 4 times because you're going to move it over to 4 times to the right because it's a large number. Large numbers have more and more zeros to the right. So I move it 4 times, put my decimal, place zeros in those empty spots, and then rewrite my number. This is 32,000. If I want to try a different one, let's take a look at the second one. It's going to be a very small number. It has a negative exponent as the power of 10. So small numbers don't have zeros to the right, they have zeros to the left. And so I'm going to go ahead and, I could write it like this, but I could also just start with 6.4 and move the decimal over 3 times, because that's what that's telling me. So 1, 2, 3. I place zeros and I put a 0 right up front, and then I can rewrite the number. The reason I put the number up front is it kind of helps me remember that, look, at the example above, move it over 4 times, okay? Move it this way 3 times and move it this way. I like to put this 0 here because sometimes students like to write this decimal really lightly. I can't really tell where it's at. But if I have a 0 between it, I know that that's where it's supposed to be. I'm going to try a couple more here. All right, so let's try these out. Okay, so once again, I've got 9.1 times 10 to the 6th. Right away, I can realize that this 6th power means it's going to be a large number. Okay, large number kind of gives you a clue as to what direction you're going to move your decimal. So 9.1, large numbers have zeros on the right. So we're going to go 1, 2, 3, 4, 5, 6, put a decimal, and then fill in these spots with zeros. I can rewrite my number as being 9, 1, 1, 2, 3, 4, 5 zeros, 1, 2, 3, 4, 5, and then I go back and put my commas where I need to. You know, this is 9,100,000. My answer there. Take a look for this one. Okay, here I notice that it's got a negative exponent. So it's going to be a small number. Small numbers have zeros that are on the left-hand side. And so we can start with 9.1. There's my decimal. And I'm going to move it 5 times. 5 times this time to the left. 1, 2, 3, 4, 5 for the decimal. Place zeros in those empty spots and put 1 right out front. And then I can rewrite this number 1, 2, 3, 4, 9, 1. That's how you write into scientific notation. Alright, so now we have this number that's already in standard form. Okay, and I want to change it into scientific notation. So how do I do that? Well, first I have to realize where my decimal's at. I have a number by itself and I see a decimal. I know that it's at the very end. Okay, and ultimately, if you remember from our notes, we want the decimal to end up so that my number is going to be between 1 and 10. So where would it be between 1 and 10? Well, I couldn't end here. I couldn't end here. That's 72. Be right here, 7.2. That's between 1 and 10. So ultimately, I want my number to look like 7.2. Okay, with all the zeros over there, I don't need to write those, so I can just write times 10. And then the question is, to what power? Well, let me find out how many spots I would have to move it. 1, 2, 3, 4, 5, 6. I had to move it 6 spots, so that's the power of my exponent. And that is considered scientific notation. Let's try another. Here's my next example. I've got a really small number, okay, and I want to change it to look like scientific notation. Again, the decimal needs to end up in between numbers where it's going to give you a number that's between 1 and 10. So that looks to me like it should end up right here, right between the 6 and the 1. Okay, if I end between the 6 and the 1, I'll end up with 6.1, which is good. That's between 1 and 10. What I want, I'll say 10 times 10 to the what power. Now, this is a really small number. Small numbers tell me that this exponent here is going to be negative. All I have to do now is count how many spots I had to move. That's 1, 2, 3, 4, 5 spots. So I'm going to say this is the negative fifth power. Okay, once you try a couple, let me know. Okay, so the two numbers I have is 9,100 and a number below it. So let's try this one here. 9,100. Well, I should have the decimal, which starts right here. I want it to end between the 9 and the 1. That makes a number between 1 and 10. And so next I just need to figure out, all right, so this is going to be times 10. This is a large number, so this is going to be a positive value. And I ask myself, how many spots do I have to move it? 1, 2, 3. I have to move it 3 spots, so that's my exponent. Okay. This next example, let's see, it's going to end up between the 1 and the 1. 1.1 times 10. I know it's a small number, so it's going to be a negative exponent. And I see it counts as 1, 2, 3 spots. This would be negative. There you go. Try those out on others.